Welcome to Homework Lib.
So in problem 100, we have a Galilean telescope or opera glasses, and we're given figure P34.100. And you're told in this problem that your object and final image are at infinity, and that the image from the first lens serves as the object for the second lens, which is the eyepiece. And your final image is virtual interact. And in part A, we are asked to find the angular magnification, or we're asked to prove that the angular magnification is minus f1 over f2, where f1 and f2 are the focal lengths. And to do this, we're going to follow the procedure that was done in deriving equation 34.25. But instead of using theta and theta prime, like they did in equation 34.25, we're going to use u and u prime, which is the angles that's given to us in figure P34.100. And if we follow this procedure, we see that m is equal to u prime over u. And if we examine this figure, we find that u, this angle u, is y over f1, and that's the object height, and then u prime is y over f2, because f2 is diverging, so I have a minus sign here. And so if I plug in u prime over u, I get minus f1 over f2, which is what we set out to prove. And now let's do part B. So in part B, we're asked to use, we're asked to look at problem 34.61 and get some information from there. So basically, we need to use, get the same magnification that they have in that problem, and also assume that our focal length is the same focal length that they have in that problem. So you're actually given f1 and f2 in that problem, and basically you have to find m for problem 61. So f1 we're given is 95 centimeters, and f2 we're given is 15 centimeters. So the angular magnification we get here is f1 over f2, and let's just take the absolute value. So then that's just 95 centimeters over 15 centimeters, and that gives me 6.33. Okay, so this is the magnification we want. So now in this problem, problem 100, we have to use the same m, which is 6.33, and the same f1, and we need to figure out which f2, the focal length of the second lens, will give us this magnification for the same focal length used in this problem, f1. So this is actually easy enough to do. So we just use the formula in part A, or this formula that we have right here, that m is minus f1 over f2. We rearrange to solve for f2. So f2 is minus f1 over m. And let's just take the absolute value here. So then the magnitude of f2 is now 95 centimeters divided by m, which is 6.33. And that's obviously 15, because if you look at this problem, when we divided 95 by 15, we got 6.33. So if we divide 95 by 6.33, we're going to get 15 centimeters. Now, since f2 in problem 100 is diverging, it needs a minus sign there. So that's minus 15 centimeters. And now in part C, we are asked to compare the lengths of the two telescopes, meaning compare the length of the telescope for problem 34.61 with problem 34.100. So here, we know this formula, length of the telescope is f1 plus f2. And over here, they had two converging lenses, so that's 95 centimeters plus 15 centimeters, and that's 110 centimeters. And in this case, it's a converging lens for f1 and a diverging lens for f2. So we have 95 centimeters minus 15 centimeters, and that gives us 80 centimeters.